Let's check an example using the definition of continuity that we have learned till now. If f of x is x plus lambda when x is less than 3, it is 4 when x equal to 3, and it is 3x minus 5 if x is greater than 3. And this function is given to be continuous at x equal to 3. Then he is asking us for the value of lambda. Right? Now, as the function was defined differently on the left side of 3 and the right side of 3 and at 3. So which definition of continuity would help us? What is the condition it should satisfy? Limit x tends to 3 minus f of x, that is left hand limit should exist, functional value should exist, and limit x tends to 3 plus f of x should exist. Not only these three should exist, what is the condition? These three values must be equal, right? So let us calculate each of them separately. First I am calculating limit x tends to 3 minus f of x. Now this is limit x tends to 3 minus. How is the function defined to the left of 3? Because 3 minus is a number which is less than 3. So how is the function defined when x is less than 3? It is x plus lambda. Now 3 is within the domain, so I can directly substitute. This value gives me 3 plus lambda. This is my left hand limit value, exist. Now similarly, what is f of 3? F of 3 is defined directly. It is given to be 4. So we calculated limit x tends to 3 minus left hand limit is calculated. Functional value is calculated. Now what are we left out with? We are supposed to calculate the right hand limit. Let's see what is limit x tends to 3 plus f of x. Now limit x tends to 3 plus f of x is the limiting value when the function is to the right side of 3. To the right side of 3, how is the function defined? It is 3x minus 5. Now 3 is well within the domain, so directly substitutable. It is 3 into 3 minus 5. So it comes to be 9 minus 5, 4. Now we are able to calculate the left hand limit, right hand limit, and the functional value, right? Now, when do you say the function is continuous? When does it satisfy this condition? If limit x tends to 3 minus, that is 3 plus lambda, should be equal to the functional value 4 should be equal to the right hand value, that is 4. Now then only the function is continuous. Now these are already equal. So what does this lambda value gives me? The value given for lambda is 3 plus lambda is 4. So the lambda value must be 1. Which option does this satisfy for us? Option is D, right? Let's check one more problem based on the same idea of left hand and right hand continuity definitions. F of x is x times sine 1 by x if x is not equal to 0, but it is defined as k when x is 0. And he says the function is continuous at x equal to 0. Then you are supposed to find the value of k. Now, here the function is not defined separately to the left side and to the right side. Only the function is defined at 0 separately, and for all other non-zero values, the function is defined separately. So which form of continuity condition would help us? Limit x tends to 0, f of x should be equal to f of 0. Then the function becomes continuous, right? Now, what is limit x tends to 0 f of x? First we will calculate limit x tends to 0 f of x. X tends to 0, therefore can I say x is not equal to 0, which is very nearer to 0 but not 0. Then the function is limit x tends to 0 x times sine 1 by x. Now this is a product of two functions. So can I split the limit? That's from algebra of limits we learned. Into limit x tends to 0 sine 1 by x. Now as x tends to 0, x limit is 0, but as x tends to 0, sine 1 by x is, remember the properties of sine. It's a finite number which is between minus 1 and plus 1, isn't it? Now 0 into a finite quantity must be 0. So this is the value of our limit, and we also know functional value at 0 is given to be k. Now let's come to the condition. But he says f of x is continuous at x equal to 0. Now when is this possible? If your limit extends to 0, f of x value is equal to f of 0 value. But what is the calculated limit as extends to 0? 0 should be equal to f of 0 value was k. So what is k value which we got? The value of k must be 0 so that this function becomes continuous at x equal to 0. Which option it satisfies? Yes, it satisfies the option C from the given answers. Now again, if f of x equal to 2x plus 1 when x is less than 1, and it is k when x equal to 1, and it is 5x minus 2 when x is greater than 1, and the important condition is the function is continuous at x equal to 1, then find the value of k, right? If you look at this function's definition, to the left of 1 the function is defined as 2x plus 1, and to the right of 1 the function is defined as 5x minus 2. It's a piecewise defined function. So how do we check the continuity of such a piecewise defined function? What condition it should be satisfying? It should satisfy limit extends to 1 minus f of x be equal to f of 1, and this value should in turn be equal to limit extends to 1 plus f of x. So which condition I am using? The left hand limit should exist, right hand limit should exist, and those two must be equal, and they in turn must be equal to f of 1. So let's calculate each of these values separately. First I am calculating limit extends to 1 minus f of x. When x tends to 1 minus, that is when x is to the left side of 1, how is the function defined? It is defined as 2x plus 1, and for 2x plus 1, 1 is a number inside the domain, so I can directly substitute. What happens when I directly substitute into this? It becomes 2 into 1 plus 1, so left hand limit exists and the value is 3. Now let us calculate the right hand limit. Limit extends to 1 plus f of x. What is limit extends to 1 plus f of x? When extends to 1 plus, you are on the right hand side of 1, that is more than 1. Then how is the function defined? The function is 5x minus 2, that is 5 into 1 minus 2, which is also 3. So till here if you look at the functional values, limiting values on the left side exist, right hand side exist, and they both are equal. So shall we say the limit exists? I need f of 1 value. What is f of 1 value by definition? The value is k. Now I am able to calculate the left hand limit, right hand limit, and also a defined value at 1. Now when do we say the function is continuous at x equal to 1? Now since f of x is continuous at x equal to 1, it should satisfy this condition, right? This value and this value, that is the left hand limit and right hand limit, are already equal. So when does the final continuity is satisfied? Provided these two are also equal. So shall I say the limiting value 3 must be equal to the functional value k. So what is the k value coming? The value of k comes to be 3, which is given at option C. So what is the correct option for this? It is option C. Let's check one more problem. The value of m for which the function f of x given by mx square if x is less than or equal to 1, and it is 2x if x is greater than 1, and this function is continuous at x equal to 1. Now what way the function is defined? So which form of continuity test would help us? The function is defined differently to the left side of 1, and the function is defined separately for the values which are to the right of 1. So this is a piecewise defined function. Therefore, for us the condition of continuity should be limit extends to 1 minus f of x should exist. Limit extends to 1 plus f of x should exist. That is, the right hand limit also should exist. And the functional value 1 should exist. And these two, all three values must be equal. Now let's calculate first. The limit extends to 1 minus f of x. What is limit extends to 1 minus f of x? That is the limiting value when function is defined to the left of 1. How was the function defined? It is defined as mx square. So this should be m into 1 square, that is m. Limit extends to 1 plus f of x, that is I am calculating the right hand limit, is limit extends to 1 plus, to the right side of 1 the function is defined as 2x, therefore it is 2 into 1. Now I am able to calculate the left hand limit and right hand limit. Now if we observe the definition, to the left of 1 and add to 1, the function is having the same definition, m into x square. So can I write f of 1 value is also m into 1 square, that is m. Now when does the final function satisfies the condition of continuity? Now the function f of x is continuous at x equal to 1 if all these three values which we got, left hand limit, right hand limit and the functional value, should be equal. That is m equal to 2 equal to m. So what is m value which we got? The value of m is 2, which is presented the option C for us, right? Now let's go ahead to function's continuity on a interval. Till now we are verifying only at a point, at x equal to 1, at x equal to 0, like that. Now we'll see how the function is continuous at a interval.